Hello friends, I welcome you in lecture number 38 on relations. In this lecture we are going to discuss about transitive closure of a relation. Suppose we have some relation R on a set A, that is R is a subset of A cross A, and suppose this relation R is not transitive. R is a relation on A which is not transitive, then we are interested in the transitive relation denoted by R plus, such that R plus includes this relation R, that is R is a subset of R plus. R plus is a transitive relation, and if there is another transitive relation containing R, then R plus is subset of that transitive relation. This means R plus is the smallest transitive relation such that R is a subset of R plus. The smallest transitive relation containing given relation is called transitive closure of a relation R. Transitive closure of relation R is denoted by R plus, and it is the smallest transitive relation that contains R as a subset of R plus. So if there is another transitive relation which contains given relation R, then R plus must be subset of that relation S. In short, transitive closure of given relation R is the smallest transitive relation that includes given relation R. Now question is, suppose we are given some relation R on a set A, then how to find out the transitive closure of that relation R on the set A, or how to find out the smallest transitive relation that contains given relation R. So for that we are going to use the composition of relations. We have discussed about composition of relations in earlier lectures, and using the composite relation we can find out transitive closure of given relation on a given set. We just recall the definition of composite of a relation. Suppose I have say relation R on a set A, and I am interested in the composition of R with itself. Then composition of R with itself is denoted by R2, and it is the set of all those ordered pairs AC from A cross A such that there exists some ordered pair B in A such that ordered pair AB belongs to R and ordered pair BC also belongs to R. If AB belongs to R and BC belongs to R for some element B in a given set A, then ordered pair AC is in composition of R with itself. And we can find out further powers of R using the composition. R3 can be obtained by taking composition of R2 with R. So all these are called powers of the relation. So in general, if we are interested in the nth power of R, then we will consider composition of n minus 1th power of R with R. So we are going to use this definition also. If you are not familiar with the composite relation, then you can watch my playlist on relations. There you will find out several lectures on composition of relations. Now our question is how to obtain the transitive closure of relation R. So suppose we have a finite set, say capital A, containing n elements. Suppose number of elements in a given set A is n, and suppose R is a relation on set A, that is R is a subset of A cross A, then transitive closure of R is given by union of powers of R, R union R2 that is R composite R, R3 that is R2 composite R, and so on, and last power is n, where n is the number of elements in a given set A. So to obtain the transitive closure of given relation R, we have to find out all these powers of relation and then we have to take their union. Now if I have n equal to say 3, then transitive closure of R will be equal to union of R, R2 and R3. So in this way we can easily find out the transitive closure of a given relation R on a given set A, and we are going to use this result R plus equal to union of R, R2, R3 up to Rn, where this n is the number of elements in a given set A on which given relation is defined. So this is what I wanted to discuss here. Definition of transitive closure of a relation. Let R be a relation on a set X. The smallest transitive relation containing the relation R is called the transitive closure of relation R. It is denoted by this notation R plus. Some authors are using R star to denote the transitive closure. So this notation is also valid, either R star or R plus. They can ask you to write down the definition of transitive closure, so you should write in this way: the smallest transitive relation containing the given relation R is called the transitive closure. How to find the transitive closure of relation R? So that I discuss that R is a relation on a set with n elements, then the transitive closure of R is given by union of R, R2, R3 up to Rn, and R2 is nothing but composition of R with itself. Similarly, we can find out any power of R by taking the composition of Rn-1 with R. We consider one example to explain that transitive closure of the relation. Here we are given one relation R on the set A having 3 elements, that is n equal to 3. So the transitive closure will be union of R, R2 and R3 because we have 3 elements in a given set. The transitive closure of relation R is given by R plus equal to R union R2 union R3. I am going up to R3 because given set has 3 elements. If given set has n elements, then we will go up to nth power of R. So first we will find out R2 and then we will consider R3. To find out R2, I have to consider composition of relation R with itself. So let me write down relation R here. It is set of ordered pairs 1, 2, 2, 3 and 3, 3, and I am taking composition of R with itself. Let me write again 1, 2, 2, 3 and 3, 3. Now we have already discussed how to find out composition of two relations in earlier lectures. I start with first order pair 1, 2. For this order pair, second component is 2. So in this set, I will concentrate on those ordered pairs whose first component is 2. Here second component of this ordered pair is 2 and I am searching for ordered pairs here in which first component is 2. So this is the ordered pair having first component as 2. So we can see 1 is related to 2 and 2 is related to 3. Therefore we will write ordered pair 1, 3 in the composition. And there is no other ordered pair whose first component is 2. So we have finished our task for first ordered pair. Same thing we will do for second order pair. Here second component is 3 and we will search for that ordered pair whose first component is 3. So this is the ordered pair having first component as 3. So we will concentrate on these two ordered pairs. I will write down first component of this ordered pair as first component, and here second component I have to consider. So 2, 3 belongs to R and 3, 3 belongs to R. Therefore here we have this type of thing. 2, 3 belongs to R and 3, 3 is also in R. Therefore order pair 2, 3 belongs to R composite R. So that is the way how we are writing these elements of the composition. So now we have finished for second ordered pair also. Now we concentrate on the third ordered pair. Here I have 3, 3. So again I have second component as 3, and here also there is only one ordered pair with first component as 3. So you can see 3, 3 and 3, 3. Therefore I must write ordered pair 3, 3. So this is the way how we obtain the composition of relation R with itself. We check for each and every ordered pair, and we find out the second component of each ordered pair in the first set, and we search for that ordered pair having first component as 2 here. So again I am repeating, I start with 1, 2, and I am searching for ordered pair having first component as 2. There is only one ordered pair, so I will write 1, 3 as the ordered pair in the composition. Then 2, 3, second component is 3. Here there is only one ordered pair with first component as 3, so we have to concentrate on 2, 3, that is in the composition. Same thing for 3, 3 and 3, 3, and we obtain 3, 3. This is the R2 or R composite R. Now I have to find out R3 also. R3 can be written as R2 composite R. So I have already obtained R2, that I am writing here 1, 3, 2, 3 and 3, 3. Composition with R. R is 1, 2. This is our relation R. 1, 2, 2, 3 and 3, 3. So again I have to repeat the procedure for composition. I start with first order pair 1, 3. So you can see this is the order pair whose first component is 3, and we can see we have to write 1, 3 here. 1, 3 belongs to R, 3, 3 belongs to R. So from this order pair I will write first component, and from this order pair I will write second component, and there is no other order pair having first component as 3. Same thing for this 2, 3, second component is 3, and here also first component is 3, so I have to write 2, 3, and here also 3, 3, and same thing here, so I have to write 3, 3. So you can see I obtain the same relation here. This is equal to R2. R3 turns out to be R2 because 1, 3 is here, 2, 3 and 3, 3. Now we are interested in the union of R union R2 and R3. So that is our transitive closure. R plus equal to R union R2 union R3, and R3 is nothing but R2. We have seen that R3 equal to R2, so let me write R2 here, and union of R2 with itself is R2. So now we have to take union of R and R2. So we will write down all the elements which are present in R as well as R2. Now relation R is already written here. So first we write these elements 1, 2, 2, 3, 3, 3. 1, 2, let me check again, 1, 2, 2, 3, 3, 3. 1, 2, 2, 3 and 3, 3. And what is R2? This is R2. So from this we will write down those ordered pairs which are not present here. 1 3 is not present here, so let me write 1 3 in the union. 2 3 is already there and 3 3 is already there. So this is the transitive closure of given relation R. We can check or verify that this relation is always transitive. So in this way we can obtain transitive closure of a given relation. You can check also because we have only 4 ordered pairs. Here if you concentrate on these 2 ordered pairs, 1 is related to 2 and 2 related to 3, therefore we must have 1 related to 3 that is present. Same thing here, 2 related to 3, 3 related to 3, therefore we must have 2 3 present, that is present here. And here for these two also we can check, 1 is related to 3, 3 related to 3, so we must have 1 3 present in this relation. So this R plus is the transitive closure of given relation R, and it is the smallest relation which includes R as its subset. You can see this 1 2 2 3 and 3 3. These 3 ordered pairs are present in given relation R, but this was not present. After adding this ordered pair, we can see that relation becomes transitive. So this is the smallest transitive relation such that R is a subset of R plus. In this way we can obtain transitive closure of the given relation. We have to just remember this formula, and we must be familiar with the composition of relations. We must be able to decide how to find out the composition of given relation with itself. So this is all about this session. I hope you like it. Thanks for watching.